All right, young people, bonding, another little lecture here on bonding. We're going to be talking a little bit more about ionic bonding or transferring electrons. So topics to understand: how can we model ionic bonds, writing correct formula for ionic bonds, and correctly naming ionic bonds. So ionic bonds that are formed by a transfer of electrons from one element to another. We know that each element will have to form an ion to complete an octet after the transfer of electrons. They are made up of a metal and a nonmetal. We always have to have a metal and a nonmetal, a metal to lose, a nonmetal to gain. There also might be something called polyatomic ions, and we'll deal with that a little bit later. So positive ion, cation, an atom has lost one or more electrons, so the charge is positive. Remember, we are minusing a minus charge. That overall is a positive. So forming a cation means that I take sodium here, and sodium wants to lose that 3s1 valence electron. So it does that, and it becomes like neon on the outside. It has neon's electron configuration, but now sodium has lost that electron and become positive. So cation names are really simple. We just simply use the name of the metal. For example, Na1 plus is called the sodium ion. Pretty simple. Negative ions are called anions. Remember, cat has a T in it. It forms a positive. An means not or negative, so it's a negative ion. So an atom has to gain one or more electrons to do that. It's negatively charged. Why? Because we are adding a minus charge. So adding a minus overall mathematically is a negative. So forming an anion, here we have oxygen. So oxygen has 6 valence electrons. It wants 8. So to get 8, it will gain 2 and become like neon. Now oxygen has a -2 charge. So we can see what's happening with its valence electrons and its dot structure there. So naming anions, the name of the nonmetal with an ending of "ide." So we have oxygen, but we have to end it in "ide." So we say oxide. We truncate a little bit, we chop some of it off, and then we add the IDE ending. So formula mania, how does this work? Yeah, this is what we did. So we had sodium and oxygen. What do we see? Sodium is a cation. That means it loses electrons. O is an anion. It means it gains electrons. So what else do we see? O is double the size of Na. Well, that means O needs to gain 2 electrons and Na needs to lose 1 electron. And we also see that in the number of the charge. So Na needs to lose 1. O needs to gain 2. 1 Na is not enough to give O all the electrons it needs, because O to be an octet needs another electron. So what will happen is we'll take 2 sodiums. 2 sodiums are needed to complete O's octet. So now each sodium loses 1, both achieving their octet, and O already has its octet. I'm sorry. I'm trying to go back. Okay, there we go. So we get the idea here. So the formula and name of new compound. So here we have Na2O. That means we had 2 Nas and 1 O, and we're going to call that Na is sodium and O is oxide, so we call it sodium oxide. It's that simple. Remember, these are binary, so they're relatively simple. So using the dot structure, understand ionic bond. It's pretty simple. Here's Na with its 1 valence electron. It wants to lose it. Here's O with its 6 valence electrons. O wants to gain 2 electrons. So Na loses that electron to O, but O is still not happy, so I need another electron. So Na, okay, Na will add another Na to get O where it needs to be. So now we have 2 Nas. I'm sorry, I keep going forward and I don't want to. Now we have 2 Nas and 1 O. Again, same idea. So what is it called? Na2O is called sodium oxide. All right, so that's where we're going to end this one today. Hopefully that will